Welcome to the Job Shop Show, where we talk with the owners, suppliers, partners, and customers of custom manufacturers. Listen and learn the secrets of top-performing job shops, the tools, techniques, and backgrounds that have made them successful, all in the quest of raising the bar for custom manufacturing. I'm your host, Jay Jacobs. This episode is sponsored by Paperless Parts, connecting buyers and suppliers of custom manufactured parts. The Paperless platform is a secure, ITAR-compliant, cloud-based manufacturing system for suppliers that reduces the amount of time spent on sales, estimating, quoting, administration, and order processing. It offers seamless integration with the accounting and ERP software tools that shops already use, such as QuickBooks, E2, and JobBoss. Paperless Parts was founded with a mission to make manufacturing more accessible by streamlining the quote-to-cash process. Spend less time quoting and more time selling.
This episode is sponsored by our friends at the NTMA, the National Tooling and Machining Association. The NTMA is an association of privately held, entrepreneurial-based, and family-owned businesses representing nearly 1,200 small to mid-sized machine shops and tool and die shops across the country. They have approximately 30 very active regional chapters that host local events, run apprenticeship programs, and provide other services to their regional members. As an association of peers, the goal of the NTMA is to help members of the U.S. precision custom manufacturing industry achieve profitable growth and business success in a global economy through networking, workforce development and training, technology, best practices education, advocacy, programs, and services with industry partners. To learn how your company can get involved with the NTMA, including how to join, visit ntma.org.
Shazam! Welcome, Job Shop enthusiasts, to another nail-biting episode of the Job Shop Show. Your host, Jay Jacobs here. Today we will be talking about 3D printing. We are lucky to have with us a 3D printing veteran and pioneer, Kevin Dyer. Kevin and I have known each other for over 30 years. In 1989, I wrote up a business plan and purchased for Santon Engineering a stereolithography SLA 250 from Kevin. Kevin was selling for 3D Systems, and they made the first 3D printer that was commercially available. Eventually, Kevin decided to get in the business of making 3D printed parts for others and started a shop, InterPRO, in 1996. I think they're one of the oldest 3D printing companies still around, and they are located in Connecticut. Kevin has a ton of background on 3D printing and has lived through all of the changes over the years. So I'm super excited to chat with him and give you a history of 3D printing that you probably can't get anywhere else. Welcome to the Job Shop Show, Kevin.
Thank you, Jay. Good morning. Happy to be
Great.
here.
Yeah, great to have you here. And we are talking in April of 2020. It's the middle of the COVID-19 pandemic. We hear a lot about how 3D printing's been mobilized to make desperately needed parts. And you and InterPRO participated in one story that was captured on TV where you printed a ventilator adapter that allows one ventilator to support several patients. How'd this come about?
I was reading the New York Times about 3 weeks ago now, and there was an article by a doctor in New York City whose article is entitled "The Sky is Falling." And reading it, she was describing the desperate circumstances and what was going to become more desperate. And she appealed to people to do whatever they could to help. And I know that one of the things that she was talking about, of course, specifically was the ventilator capacity. So I think somewhere I'd heard and read that physicians were cobbling together extensions on ventilators to support more than one person with one ventilator. So it seemed that that was an obvious thing, that if it was designed to be able to be 3D printed with multiple ports, that would be something that we could do that might be of help. So I contacted the local SolidWorks users group, and I asked them to put out an email to their group to request people who might be able to design such a device. And then word traveled, and Bob Conley, who's on that email trail. Stepped right up, and I think the next day he sent an email saying that he had two designs for a manifold, basically an adapter that
Mm-hmm.
would, in his first design, take one outlet and feed it to three or four. He did two different designs.
He has his
So
own design company?
I've known Bob for a lot of years. Interactive CAD Solutions in Lebanon, Connecticut, and
Okay.
Bob's a senior level designer. He has also 3D scanning capability in his house
Hmm.
where he works.
Okay.
So I got in touch with Bob when he sent me the email, and we started to talk about how we do this. And the first question was, well, what's the diameter? What's the right diameter for that entrance and exit port? So
Mm-hmm.
through some other friends, I was able to get a ventilator tube from a anesthesiologist. I met Bob at a Dunkin' Donuts. He took it home. He measured it up with his scanner, and
Mm-hmm.
in a matter of about an hour or so, had things dialed in as far as the port diameters. Sent us the file, and we started printing them on RSLA. And then after the first launch on SLA, we also scheduled to get it on the HP printer. So the next day, I've lost track of all the days, but the next day we had that in hand. And
Mm-hmm.
when I had when I was also talking to the CAD user community about how can we work together to get a design, the other question was, well, who do we take this to? Who do we
Mm.
talk to see if this is possibly going to be helpful? So through
Right.
some other friends, some emails were sent, and I was contacted back by a doctor at Manchester Hospital in Connecticut, and he said he was interested and wanted to have it when we printed it. So I think it was the following morning, Bob and I met him at the hospital, and he took these right in and fitted them to his ventilator. Got some very positive first fit check results, had some
Right.
ideas for how to optimize the design.
Mm-hmm.
So Bob went right back home, did some more modification on it, made it more compact to fit
Mm-hmm.
into the space that was available. And again, sent us a file. We printed it that night. And I think it was that was, I think, a Saturday or Sunday morning then that we went back and we had the second round of tests. And if there's pictures now on the internet of that ventilator assembly that he put together where he fit 7 balloons, test balloons, to this
Hmm.
network that was
Okay.
created with the help of the adapter. So
That's an amazing story, and it happened so quickly.
it did,
That's the power of 3D printing and
yeah.
scanning and 3D CAD and people just coming together.
It was amazing because while we were doing that, I mean, there were so many other people that responded back to
Mm-hmm.
that mail by Ed Poole's SolidWorks users group here in Connecticut. People who wanted to get involved. They had CNC capability, they had injection mold capability, um, flow analysis capability. So many people
Mm.
wanted to get involved, and it was, it's been a nice experience from that point of view because, I mean, everybody wants to do something in this situation, and to be able to have something that maybe was going to be of value was a very, very nice thing for all of us involved in that.
Well, thanks for taking the initiative there, Kevin, and getting it out there and giving the doctors a solution.
What's really cool, Jay, is that it's been downloaded across the world. Bob Conley has a tracker on his website where
Mm-hmm.
that was the other thing. We wanted to make sure it was available everywhere. So we put it
Mm-hmm.
on Bob's website. We have it on ours too. But Bob's tracking the downloads, and it's been downloaded in over 100 countries and over 1,000
Wow.
downloads. Yeah, Zimbabwe, all over the world. It's been amazing.
Wow.
So, yeah.
Excellent. Excellent.
Yeah.
You mentioned the SolidWorks users group, and I've been working with the SolidWorks users group for a long time. Actually started with CAD key user groups and Pro engineer user groups, but the SolidWorks user groups of all the CAD communities has just taken off. And maybe you could share what the SolidWorks user group is from your experience and why you think that they are such a tight community and taken off so much.
Well, I think that's a great question. So I'm not a CAD person myself. I never learned CAD, and I'm not an engineer by background. But it's amazing when I go to the meetings, the camaraderie and the
Hmm.
enthusiasm and the real passion, the passion that
Hmm.
engineers and designers have for what they do, and especially with the continuing. I mean, it's what, been 20 years at least of SolidWorks being around. The continuing growth in its capability, that every year there's new capability, and you see the passion and the excitement in how they talk and how they react
Hmm.
to it. And it's been, you and I have the background that when we first started back in the day when 3D printing was just getting going, I think Aries was the CAD package that had an STL,
It was the only CAD package, wasn't it?
only CAD package. And
So so just for the listener, that's Aries, ARIES Technologies. They were in Lowell, Massachusetts, and they used 3D solids, I think Boolean operations to make the shapes, if I remember correctly.
so you're right, that was the only one at the time. And
Yeah.
my excitement at the time was that we had this incredible stereolithography capability, and I'd become a salesperson for it. But like, who could use it? You know.
Right, right.
So yeah,
And shapes that were more amorphous, curvy, what you would think of injection molded, were just not able to be modeled to be made on the stereolithography machines.
yeah.
Uh, and that I was going to ask you and start talking way back, because again, we may have even have met in 1988 when you first started, and Santon was talking about getting a printer in house, but I'd forgotten about the CAD system part of that. That the tools have evolved. The Certainly 3D printing's evolved, but the tools to support it have evolved too. Yeah.
Yeah. I remember as a salesperson very early on, it was easy to get people to talk to you about stereolithography. When I first started the job, there was stacks of hundreds of lead cards where people wanted to know more about it.
Hmm.
So instantly the conversation becomes like dead ended because, well, there's no way to actually get data into the machine. So I can remember calling McDonnell Douglas. I think I forget the name of that CAD package at the time, but it's like, they were about to release it. So, and that was a big one when they finally whatever that CAD
Was
package.
that Unigraphics?
I think it was Unigraphics. I think that
Yeah.
was it. Yeah, because that was huge at the time.
Hmm.
Yeah,
And I remember the first part Santon printed was for a company, a connector company called Amphenol, I believe. And connectors were actually a great fit because they were not easily made by a model maker. You couldn't really CNC machine it. And to prototype a connector before that, you had to actually make the injection mold, which cost a lot of money. But at the same time, it fit the CAD technology that was available because it was a lot of rectilinear shapes that were put together to make a connector. Uh,
I'm
but
really curious, Jay. I've never really known how you and Drew and the company got keyed into stereolithography. I mean, you were amongst the very first, and for a company of that size to make such an investment was very that was a big decision. That was a very expensive machine.
I I'll pat myself on the back and say I was a good salesman, and my sale was to Drew Santon, and getting him to spend a lot of money, because what was it, about 250,000, and then how much more money in the ancillary equipment to support it.
Yeah,
So the investment, and this was back in '89, so the investment was pretty significant. It wasn't a technology that was really proven, but we just had the inkling that it was the right direction to go. And Santon Engineering was a classical model shop. They had model makers who would use wood and metal and you name it to create both functional and appearance models for companies designing new products, and in particular, Santen focused on industrial design firms. So we had a breadth of business across different industries. Um, in answer to your question, it really was a leap of faith on Drew's part, and part of it though was the first mover. And I drew him a map. I think we were the 10th stereolithography service bureau in the country, and I drew a map and I showed the nearest one was down in New Jersey, Laser Prototypes, and said, we can own New England in this technology.
Mhm.
And the part of the pitch, if I remember correctly, was that you needed somebody to make sample parts for your prospects. They had to try the technology out before they would invest. And I
Yeah.
thought that this was a great collaboration, that by buying the machine, you would actually become a salesperson for us.
Mhm.
And your goal was that people would want to buy so many parts that they would want to buy their own printer, of course.
Pure and simple. Yeah.
Yeah, yeah.
But it
I
worked
remember
out well.
it
Yeah.
did. It really was a great collaboration and teamwork there. Yeah. And I remember, I think Johnson and Johnson was one of the first local customers. Who were some of the other first adopters of stereolithography for you?
There was Tupperware in, I think, Smithfield, Rhode Island at the time.
Mm-hmm.
Um, maybe that was a couple years after you got yours. Pitney Bowes was the first company I sold to. That was in December
Hmm.
of '88.
Yeah, that's right.
Yeah,
Yeah,
in Shelton, Connecticut.
yeah.
Yeah.
The materials have evolved quite a bit too, because the first material that was printed was a cyanoacrylate. Essentially, think of super glue.
Mhm.
And if you
Yeah,
looked at these models wrong, they would break.
that's right. Or at least warp.
Yeah. So,
Yeah.
yeah,
And they didn't smell as good.
they didn't
They did
smell
not.
good. And we use the term 3D printing now, but back then it was just called a stereolithography model. And the SLA, what's SLA stand for?
Stereolithography apparatus.
Yeah. And the 250, that was that the first printer or first
The
SLA machine?
SLA1 was the first.
Okay, and
SLA1.
then they renamed it.
Yeah. I think
Yeah,
'87 was when the first machines went out. I think Pratt and Whitney was amongst the first to get a machine, and
that's right.
there was a medical company in Chicago. I don't remember their name.
Was that Baxter?
Baxter. Mike
Yeah, it
Meck was
was.
one. Yeah.
Yep.
Yeah.
Yeah. So, well, it's been quite a journey since then. How did you see it evolve when you were working for 3D Systems? Did it sort of hockey stick in, or was it a tough sell? Just share maybe some of the parts of selling the printers or the SLA machines.
Well, it was frustrating, and it was really a challenge. And I had many a conversation with my wife as to whether or not this was going to be a future worth
Yeah.
pursuing. But I guess I had a passion for it, and I saw how it was being used at places like Pratt
Mm-hmm.
and your company and others. And I just felt like this is definitely going to become easier for me to sell as more and more people learned about it, and talk to people like yourself and others who are using it. But it was a slog. It was really hard because obviously $250,000 at that time in 1988 was, what is it now? I mean, that's a lot of money. And,
Yep.
I started selling it when it was fairly new. And of course, capital budgets weren't in, you know,
Mm-hmm.
planned. So what company has 250 or more, $300,000 available to spend for a new technology that has almost no history to it in terms of payback?
Right.
So companies like Apple, who were of a different point of view about it, believing that it had capability. I think Kodak was a very early one too.
Right.
Very big companies with very deep pockets who did a lot of R&D and had a history of buying something to see what the value might be in it.
Mm-hmm.
Companies were there, but I didn't find a lot of those companies. So it was a slog. It was very challenging, and as you said, compounded by the fact that the materials were really poor in hindsight,
Mm-hmm.
and such. Yeah, but little by little, it got easier as more and more people, more and more press, and more stories came out about companies that were using it successfully, and as more and more people use service bureaus, and it started to travel and gain faith in the organization. One of the hardest challenges I ever faced in selling a system was I think it's okay to say it, U.S. Surgical, who
Mm-hmm.
I felt was, U.S. Surgical was really in its prime when I started interfacing with them. They were really on a tear because they had a technology that they had created, and they were making a lot of them and making a lot of money. And I
Mm-hmm.
felt that my time was going to be very well spent there. And there was a lot of enthusiasm on the part of the engineers for the technology. But when it gets to bubbling up to the top, and getting capital budgets allocated and such like that, this is an example of one that was really a challenge, because when I spoke to the VP of engineering at the time and I was describing to him the value of the technology, how it helps engineers
Mm-hmm.
find possibly mistakes in their design, he said to me, I expect my engineers not to make mistakes.
Great. Yeah,
I,
that
I,
never
had,
happens.
I had no comeback for that. And it took 7 years before U.S. Surgical finally did buy an SLA.
Wow.
And of course, they've done very well with that technology and other technologies since then. But so there was a lot of resistance in terms of it's not a familiar technology. It certainly never. It was so far from being what it is now, which is an essential technology for engineers.
Who was the first competitor that came along to 3D Systems? Was that Stratasys?
Uh, Stratasys, I think, was about at the same time. Yeah, and I think um, the company that started the SLS technology. I'm trying to remember now. Um,
Oh, yeah. It,
was it was it
the
DTM?
lasers.
DTM
DT. Yeah.
in Texas, yeah. So they were out of the gate.
Maybe actually, can you describe just generically? I think most folks know how 3D printing works, but the difference between the SLA and the SLS, which was DTM, and SLS stands for selective laser sintering, and maybe the
Sure,
FDM fused definition deposition modeling.
sure.
Yeah.
So there's those three basic technologies. There's the powder based, the liquid based, and the filament based. So the
Mm-hmm.
filament based is the one that I think most people are personally familiar with Maker bots and all the variations of that are now available, where you basically have it's a glue gun sort of,
Right.
where you pass a filament, a weed whacker string. A lot of people say pass a weed
Mm-hmm.
whacker string through a glue gun, and then you move that glue gun around. So that's basically, it's a very simple process, and that's been around since pretty much the time SLA started as well. SLA is photocurable material, photocured with a pinpoint or a spot of light on the surface of a vat of liquid, and
Mm-hmm.
that's usually supplied by a laser, which dances around very quickly.
So when you say photo cured, it means that it turns from a liquid to a solid when it's exposed to a certain frequency of light,
Exactly.
and
That's
that
it.
laser gives it that. Yeah.
The laser gives it that, and and then the SLS technology, and all of these, of course, are layers. The SLS technology is using a powder of a nylon, for
Mm-hmm.
example, which is also subjected to a laser. But in this case, the laser is a very high intensity laser, which supplies a tremendous amount of heat in that pinpoint of light that's hitting the surface of the powder. So the powder literally melts and it pools. And as that laser travels around, it leaves a pool of molten liquid, but it quickly cools and solidifies. so you get a solid trail. And little by little, that layer is created, and then more in each of these, another layer, in this case powder, is distributed over the previous layer of powder. In SLA, more liquid is distributed over the previous layer of liquid.
How about tolerances? How have the tolerances improved from the first machines?
Oh, they're about the same.
Yeah, right.
It's crazy how good they are. I mean, I see parts now that I just can't believe. I just can't believe they're 3D printed.
Mm-hmm.
InterPRO has our technology foundation is still very much SLA, but we also have Origin 3D printer in house
Mm-hmm.
now, which is a DLP similar to a Formlabs. I think is a Formlabs, might be
Yeah.
a DLP as well. But the parts that I'm seeing coming off of this particular technology and the latest SLA technology, the tolerance and the feature definition are outstanding. Sometimes it's really hard to look at them and believe that they're a 3D printed part.
Yeah.
So, and that's of course because the hardware and the software have evolved so far, but also the materials have evolved so far.
Mm-hmm. I'm curious, you have lived through the different names that this technology, we refer to it now as 3D printing, but that's a relatively new way of describing it. And I know we've called it additive manufacturing. The SLA was sort of a generic name for anything that was made. But what other names were there, and why do you think 3D printing is stuck?
That's a good question. I think it makes sense. I'm not sure I ever really thought about that. It seems like just an obvious thing to call it.
Yeah.
Yeah, stereolithography. Fortunately, we don't have to say stereolithography anymore.
Right.
I was glad when that kind of went away. Yeah.
And the phrase a service bureau has gone away too. But that was pretty common in the 90s, that you wanted to get a SLA part or any of the technologies from buy a part, you went to a service bureau.
Sure.
And that sort of moved away, I think, in the 2000s. But I thought it was actually a pretty good description of what we did.
Yeah.
Yeah.
Yeah. I still hear the term a lot.
Do you still hear the term a lot?
I do. Yeah.
Hmm. I'd be interested in getting your perspective on, I have my opinion, but 3D Systems bought up a lot of the service bureaus, a lot of the independent shops making parts, and particularly the larger ones across the country. And they had at least the idea or concept that they were going to be a real big part making company. How do you think that played out? Why don't you think it worked? And what do you think the impact was on the industry?
Well, I do have some feelings and thoughts about that. When as a service bureau owner, when that was
Yeah.
going on,
Yeah.
that was a rather crazy time, and the price tags that 3D Systems was paying for these service bureaus was off the charts crazy.
Right. It just didn't make sense not to sell your business to them.
Right, and I just kept waiting for a phone call. And I
Yeah.
never got a phone call. And be careful what you wish for, because not a lot of good has come out of that, in my opinion, in terms of the um, I'll use the word decimation, the
Mm-hmm.
decimation of some very good companies.
Mm-hmm.
I hesitate to name them because I don't want to embarrass anybody, but some very good companies with very, very skilled and hardworking employees who, I mean, were just blown apart by this. And
Yeah.
the stories of how specifically 3D Systems would take ownership of a company and then just put the thumb down on it and force them to radically increase prices.
Mm-hmm.
And at the same time, hold them responsible for profit objectives that the owners had signed up for.
Hmm.
So, I mean, I've heard some really appalling stories, really good service bureaus that you and I both know of, having had terrible fates and just disappearing.
Yeah, they disappeared, and
It, yeah.
and beyond what you just described, our 3D Systems sort of arbitrarily decided that certain service bureaus would focus on certain things, so they just closed down part of it. And what I saw was the revenue from the service bureaus that they bought, every single one decreased dramatically until, from a stock point of view, shareholder point of view, it didn't make sense for the company to be making parts anymore, and they just shut it all down. So they spent uh, well into the nine figures and took out probably a dozen or so of the leading service bureaus in the country.
I'll tell you a story. When I was traveling a lot, when I was at 3D Systems, I covered down through the South and a lot of
Hmm.
places. And one day I was in I think, South Carolina, and I was meeting with our local rep down there, a gentleman by the name of Tom Clauser,
Hmm.
who said something that always stuck in my mind. He said, Kevin, he said, every business is a people business. And
Mm.
I think that getting back to what we're talking about, the companies that grew, like DPT
Hmm.
and Laserfair and
Hmm.
uh, and SciCam, who still is in operation and doing very well. These are all companies that are founded by individuals and that were able to I'd say appeal to people, engineers particularly, on a one-to-one level, and to be problem solvers and to go out of their way to help. I mean,
Hmm.
when you're a family startup, especially when you're a family company, you do everything you can. It's within
Yeah.
your power to satisfy that customer, and you're sensitive to the customer's needs, and you have
Hmm.
to, and especially price, but delivery and all these other things. When a corporation takes over, it's that disappears in many of these circumstances, and to have, you know, a corporation such as 3D Systems pushing down from the top to meet certain sales objectives, et cetera. The essence of the people relationship with customers had to disappear in
Hmm.
cases that I'm familiar with.
I'm also going to throw out, Kevin, that I think that innovation occurs in the smaller shops as well. And the story you told about the ventilator adapter is a huge one, that as a owner of a small business, you have the freedom to do that. And I remember, because I was very familiar with a lot of the service bureaus, there's a ton of innovation because the service bureaus had to figure out ways that potential customers could use their services. So they were inventing uses and documenting those for customers and really pushing the industry forward. And so here's my opinion that it doesn't get heard a lot, I don't think, but 3D Systems is often lauded as the company that created the 3D printing industry. But I think in the 2000s, with them buying all the service bureaus, they set back 3D printing by 5 to 10 years because they took all that innovation of 3D printing out of the system. And they they yes did a lot of things that pushed the industry forward, but they do have a lot of responsibility for essentially stagnating the industry for a number of years. And not just the 3D printing industry. I remember in the scanning industry, which you're familiar with as well, there were some key software tools that are used by the scanning companies, and they essentially bought up these these companies. They brought them together. So now there's no competition between companies to make their products better, and they shut down the innovation for scanning as well.
Mm-hmm.
I think 3D Systems really needs to get called for their legacy uh, in doing these things.
Yeah. Well, I know that we're talking in a way that might be edited out, frankly. But I'm sure you do too. But I've heard a ton of stories about the quality of the equipment that they were shipping, and when you ship a piece of junk
Mm-hmm.
that's that's not tested and it's not manufactured right
Mm-hmm.
to a small business, and that small business is very, very painfully, badly impacted by the lack of performance of that machine. That's it's not a good thing.
I totally agree, and I think that the irresponsibility, and I'm going to use that word, and I don't think we will edit this out, Kevin, because I have sold my company. I'm not beholden to anyone, and I really want to not have mistakes like this made again. 3D Systems bought other 3D printing companies, and whether it was intentional or just bad management, they took these wonderful companies, and I'll say specifically Z Corp is one that you and I both know pretty well, and they essentially that company evaporated. And there are specific stories where they did not support the customers after the sale in a very good fashion. And all these things really stagnated the 3D printing industry for quite a while. And I think as a leader in an industry, whether it's 3D printing or anything else, you have a responsibility. So that's get off my soapbox now, but
Well, that's part of the reason that I left 3D Systems when I did, because after after 6 or so years, and momentum was growing, and I was having reasonable success as a
mhm,
salesperson. Um, it was a very challenging situation to be in, and my
mhm,
fellow salespeople from around the country,
mhm.
all of them really hardworking people.
Yeah, a lot
Um,
of the service bureaus were started by ex 3D system salespeople, weren't they?
I think so. I
Yeah.
think so.
Well, tell
But
me a little bit about InterPRO. Tell me about that, how you did get started.
well, I was starting to say that I was really I was looking at the success that people who had started companies were having. I mean, it was there was a growing number of companies that
Hmm.
were startups that were doing very well. And in my particular situation, I thought, how could I do that? But I didn't have the wherewithal capital wise. I didn't have any. I didn't try to find any equity partners to go in, and I thought, well, maybe that ship will never sail for
Mm.
me. But one day, changed my life. I got a call from Bill Soares at Swarovski Jewelry, who I had sold an SLA to.
Hmm.
Swarovski bought an SLA 250 with the idea that they could 3D print prototypes of jewelry.
Hmm.
And I forget the CAD package that they bought with it, but it was a very, very expensive and very, very difficult to use CAD package. And their designers, who had always designed just on paper, were being asked to learn CAD and to 3D print.
Yeah.
And it was not a good idea. It was a non-starter. So the SLA was turned off before very long.
Hmm.
And I got a call one day that they were looking to find a home for it,
Hmm.
and that's what changed my life right there.
Hmm.
I had a 401k. I liquidated it. I bought that machine, and
Wow.
I
I
parked.
didn't realize that. You took your essentially your retirement savings then.
Yeah, yeah. And I bought that, and I parked it in a rented space that I had.
Hmm.
And then it's like, well, what do I do now? So one of the happiest moments of my life was when I get that machine turned on and it actually started going up and down. I was like, I was a kid at Christmas. It works. So, but I didn't have a business plan. So I set about for the next year or so putting a business plan together, and
Hmm.
was able to at about the same time, miraculously, Loctite, who at the time was a supplier of 3D printing resins for SLA, it became known to me that Loctite was getting out of the industry.
Mm.
by SLA resins. And therefore, their SLA, which they had in their Connecticut location, was no longer going to be of any use to them. So
Gotcha.
I made phone calls, and I was able to secure that machine. I bought that machine too. So I had two SLAs,
Mm-hmm.
and I put my business plan together and got some funding. I was able to the bank looked at the value of the SLAs as my equity.
Mm-hmm.
And I announced to 3D Systems that I was going to be going out on my own. And to my great surprise, they offered, and you'll appreciate this, they offered that I could become a reseller for the Actua.
Oh, the actual, yeah.
If I
Yep.
wanted to.
Yep.
So, and I think you were a reseller for the Thermojet or Actua.
The actual became the Thermojet, right?
Thermojet, right, right.
Yeah.
So that to me was just an absolute wonderful occurrence, because that machine was starting to really get traction.
Mm-hmm.
And when I got operational, we shot up to almost $2 million in sales in 2 years.
Wow.
That was a blessing for me.
Huh.
And of course, when 3D Systems decided to end all reseller relationships, that was a very bad day for me.
Yeah. So
Yeah.
you started it was 1996?
I think it was, 96, 97, I think maybe 97, 98 time frame I got started.
Yeah. Okay.
Yeah. So
And
we had
the
one
Actua, and just for the listeners, the Actua and Thermojet was more of a desktop. I wouldn't say desktop, but more of a large plotter, like an HP plotter size printer, and the material was wax, so it was really good for metal castings. At least that's what I found.
inkjet
Yeah.
technology.
Yeah, that's right. Inkjet
Yeah.
technology.
And it worked great, and it made really nice parts, and it
Yeah.
was easy to run.
Yep.
So we started with one SLA, and then the second one got turned on,
Mm-hmm.
and that's how we got going.
I want to get into how you evolve with the printers and the different printers you use, but before that, we're facing what I think is going to be a tough business climate after this is all said and done. And you went through 9/11, which for me, the 2 years after that were just brutal in a parts making business. 2009 certainly wasn't much fun. Why do you think you survived, and you're still not just surviving, you're thriving now?
I consider myself very lucky, really.
Well, I think you must have created your own luck, Kevin.
Long hours,
Yeah.
long hours. Having to, of course, I mean, payroll had to be reduced severely.
Mm-hmm.
And hours you just had to do everything you possibly could. And, there were times that I was, making prayers to God to just, help this SLA not crash tonight, because I had
Yeah.
to go to that part tomorrow.
Yeah.
And so a lot of late nights, and yeah.
And that you just made a comment that I think is really relevant, because the printers are so much more reliable today, but they did used to crash.
It crashed a lot. It crashed a lot. And you
Yeah.
see, part of my challenge is that I'm not a mechanical engineer, and I'm not a designer either. So I was, I was pretty much out of my element in terms of the things that I put myself in the middle of. And, would I do it again? I'd say I would do it again now, knowing what I know now, which is that it's possible to do it. But if I had my druthers, I would have done it with some other members of my team that had the background, certainly like you had, mechanical. Yeah.
Well, I think I'm more along your lines, as I can tell you why it doesn't work, but I can't fix it. So you you started with the two SLAs. You were probably selling parts off of the Actua and Thermojet. What technologies did you bring in house next? And how did that sort of path and bringing services in-house, and what are the services you do today?
Sure. Well, one of the technologies that I also, I had talked to Michael Center, who was the US rep for Camatini, about the technology that they were marketing at the time, which was, if you remember it, it was a cast urethane system
Mm-hmm. Yep.
that was almost self-contained. And he demonstrated it at trade shows with enormous results. I mean, beautiful parts being made right at the trade show.
Mm-hmm.
And it was a nice compact system. And I thought it would complement the sale of parts, but also the sale of the Actuant thermojet as well. So we became a reseller for that. And by doing that, we got directly involved with making cast urethane parts and rubber
Could you
mold.
just tell the listeners what cast urethane parts are, how that
Sure.
process works?
So it involves plastics where you mix the A and the B, and they catalyze and they become solid.
Mm-hmm.
And in a cast urethane process, you're putting those typically into a rubber mold, and the rubber mold is usually made of some type of silicone rubber.
Mm-hmm.
And so to create that silicone mold, there's a reasonable amount of skill involved with making
Mm-hmm.
that.
Oh, yeah.
But in the case of using SLA, the process is to build the pattern of what you finally want to produce, put it in a box, pour liquid silicone over it, let it cure.
Mm-hmm.
Next day, you come back, you take the box off of it, you cut it open at the parting line, you take out your SLA part, you pop your mold back together, and into that mold, you pour your two-part urethane. You mix your A and your B, you pour it in, and in a short amount of time, typically, it solidifies, you pop open your mold, and there you have a perfect replica of your original SLA pattern.
Why wouldn't you just make, say, a dozen SLAs instead of making one SLA and then a dozen urethane castings?
Sometimes it would be a lot faster. It's often a lot faster just to make a dozen SLAs than to do it by casting it. But then you get into the material properties. So if the material, if for the application, the material wants to be slightly flexible or very,
Mm-hmm.
very flexible or very, very rugged and will take impact, if you throw it against a wall, it won't break.
Mm-hmm.
That's the key right there. You're able to use the SLA to get to a much more interesting engineering type of material property.
Gotcha. And the silicone molding that you do you use rubber molds for that?
Typically we do. Once in a great while, we'll machine a mold if it has extremely tight tolerances or details. But we've had very good success with 3D printing the molds as well on SLA.
Oh, really?
Yeah.
I know that's always was a holy grail for 3D printing, is making tooling. Where's that stand in the industry now in making a mold like that? What do you have to do, a lot of post-processing or
For the casting of a urethane?
for the mold before you can pour material into it?
Well, again, back to the quality of the SLAs now with the technologies that are available and the materials that are available,
Mm-hmm.
they lend themselves very well to this, especially for a silicone part, which if you're casting a flexible part, there's much less risk of it breaking the SLA when you pull it out of the SLA mold. If you're casting a very rugged, stiff part, then your chance of breaking the SLA mold is much higher.
Okay.
So we can do quick turn. We can design a mold. For example, we use Space Claim as well as solid at InterPRO, and Space Claim has been a tool for us that's really helped us to, especially to do that, to be able to take the CAD file and to design up a 3D printed mold that will 3D print. We can print it that night, and the next day be casting parts and shipping them. In extraordinarily tight circumstances, we can do that. It's not something we do every day, but it's within our wheelhouse to do that.
Yeah.
Yeah.
On your website, you also say you do custom finishing. What does custom finishing mean and I'm going to use the term model shop because you guys do produce models?
So when the parts come out of an SLA or an SLS machine or any other 3D printed part, they are what they are.
Hmm.
But if the client is looking for something that closely resembles what the actual finished product is going to look like when it's on the market,
Hmm.
if they want to take this idea and go up to their board of directors or
Hmm.
go to the client, if they want to go to Walmart and say this is what we are proposing, it
Hmm.
has to look as close as possible to the real actual finished product. So that's the skill set we have. We have some really excellent people on our team that do this and have decades of experience doing high quality finishing to parts. It's all hand finishing. Of finishing
Yeah.
the part to bring it up to a level and painting it and putting the right textures on it. And if it's got a elastomeric grip, adding a little bit of a cast urethane or cast silicone
Mm.
on there to complement it so that
A
if we
lot,
do
a lot of time it's beyond I guess the finishing even, it's the assembly of different
that's
types
right.
of components made from different materials and processes.
We had the opportunity to do some work recently, which involves the mission to Mars and to the moon, and
Oh,
it involves some hardware related to the astronauts, which
huh,
we can't really talk about too much. But some examples of our work are in Air and Space Magazine. Uh,
really?
it having it having been shown down in the Capitol Rotunda. But it's the best project and the most exciting project we've ever worked on as a team. It was an
Hmm.
amazing team effort to create these um, devices, which
Hmm.
are pretty much. I mean, if you would look at it, you would think it was the actual component made of aluminum and other stuff.
And
Yeah.
that's the goal, is you can't distinguish it from the actual production parts.
Exactly. That's it exactly.
You mentioned CNC machining, so you've got that, but I'm really curious, how many printers do you have in house now that are making parts for customers, and what technologies are you using? Because one of the things that I see, just because of your decades of experience, but as well as the people and the technologies you have in house, is you truly have the right tool for the the right job, the right application. You're not a uh, hammer looking for nails. So tell me a little bit more about the printers and why
Sure.
each one exists.
Well, we started with stereolithography, and that's still a very strong capability of ours.
Hmm.
We still have 3D Systems SLA operational, but over
Hmm.
the past few years, we've been investing in Union Tech
Hmm.
SLAs. These are very large. I think the envelope is 32 by 32 in X and Y, so we can make very large
Wow.
parts, and they're incredibly accurate. And so we're running three different materials in those three different machines, and we're also running in our SLA machine from 3D Systems. We're running Somos Perform, which is a ceramic material, which is
Ceramic.
ceramic
Huh.
fill. So it's very high heat resistant, and
Hmm.
it's not a general usage material because it's quite brittle.
Hmm.
But for certain applications, it's effective. So we have four SLAs. We have two Mark Forge systems,
Hmm.
those are excellent technologies, and that's an FDM process, of course, and that has the option to have the fiberglass infill to make
Mm.
it, or carbon fiber infill to make them incredibly strong. Great technology. We have a Fortis. We print ABS on that and occasionally polycarbonate on that, a Fortis 400. And
The
we have
Fortis
the,
is I just want to, Fortis is
yeah,
an FDM, the glue
that's
gun
right.
type machine. Yep.
That's
But
right.
very,
Yeah, that's
but very accurate. Glue gun doesn't really
right.
give credit to how accurate these types of parts are
That's
and how
right.
strong they are.
Yeah,
Yeah.
yeah. It's really an excellent machine. The Fortis is an excellent machine. We also have we have a Form Labs, which occasionally we use for some interesting small work. But we're really excited about the Origin. Well, we have two HP jet fusion machines. We're an HP reseller. We have a
Hmm.
580, which is the color machine, and we have the 4200, which is the larger machine, the original machine that HP brought out about 3 years ago now.
Okay.
When I was at Rapid about 3 years ago, and I saw that running for the first time, I just knew absolutely that that's a technology that we had to have if we're going
I
to
want to come
compete.
back to that, but you mentioned the Origin as well.
Yeah, so the Origin is a fairly new technology. It's a DLP. And what we're excited about is the material properties that are available for it now, but the material properties that are coming, including FST, uh, flame and smoke FST. I'm forgetting what the FST means, but
Okay.
basically means aerospace can use it. You can put it on an
Oh.
airplane, and it won't create toxic smoke if it's
Hmm.
subjected to heat. It won't burn, and it won't
So this
emit
is a
toxic smoke.
production part application.
Absolutely.
Huh.
And so that would be groundbreaking to have a 3D printer, especially one that creates such incredibly highly accurate and highly detailed parts. We think that this is going to be really transformational in our business. So we're standing ready to, and we have one machine, we have another one coming. We're ready to invest in
How
more
much
of
do
those.
those machines cost?
Well, they have an interesting price model, which actually I'm not even capable of commenting on, not because I'm being coy, but because I don't really understand it. And that's something I'd have to refer back to Dan Straka. We have interesting conversations about that, and I don't even want to pretend to understand
Okay.
how that's priced. But I think it's kind of a work in process in terms of how they're pricing their technology. As it's a brand new technology, and they're just getting their initial machines out the door. But we were fortunate in that we're able to um, build a relationship with them early on. And especially we're fortunate in that Loctite is supplying materials for that technology. And we've been able to build a very good, strong cooperative relationship with Loctite, a partnership
Mm.
sort of level relationship. So with Loctite materials and the Origin, we see in that particular technology a very, very bright future for all involved. But it's fact.
That's what I love about this is the the strides forward are not stopping. People are saying, when will 3D printed parts be the norm? And it's not going to be overnight. You're not going to flip a switch, but these are the incremental steps that are how we can rethink how parts are made. And so that brings me back to the HP. And I've seen the parts off of the HP printers, and they're fantastic. They look and perform like injection molded parts. And in fact, I was at I'll use the term service bureau in Phoenix a couple months ago, and their whole business is primarily working with injection molders who have orders for parts, but their tools are delayed or haven't arrived yet, and they are doing the part making for injection molders in the interim. Again, HP, they took a long time coming to market, but super product. Why are you not only using the technology, but why are you a reseller for HP? And who are the sort of people who are buying the HP printers?
When I first saw the HP at Rapid a couple of years ago, like I was saying, I knew we had to have that
Mm-hmm.
as a capability at InterPRO. But literally that same day, as I'm standing in line to put my order down, I'm listening to them talk about setting up the reseller channel, and I said I'd like to have that conversation with you, because at the time we were also a reseller from ArcForged.
Mm-hmm.
Thought, we have the infrastructure already of a sales organization for selling 3D printers. This would be a natural, and the technology was so exciting.
Mm-hmm.
I I really want to be really involved with this technology. So, and my feeling has been all along. People have said, like, you're a service bureau, but you're selling the machine too. Does that make sense? And my own personal feeling is that buy from a man who owns one.
Mm-hmm.
You know, I run my business with it, and I'm comfortable being able to say to another person, this machine would help your business as well as it's helped mine.
Well, without naming any customers, and you're welcome to name them if you want, but who are the types of customers who are buying the HP printers, and how are they using them?
Um, of course, the price tag is fairly high,
Mm-hmm.
especially on the first generation. So industrial clients, I probably shouldn't name any
Right.
names on, but of course, as you know, it's a whole a whole range of different technologies in terms of the industries that they're in. And if a company's making parts that are going to be 3D, injection molded, the as you said, the fit on these parts, the the functionality of them,
Mm-hmm.
uh, the tolerances, it's really radically improving the level of 3D printing and what engineers can do with them. And to your point earlier, I was talking to an injection molder the other day, and he's a person who for years has looked at 3D printing tooling.
Mm-hmm.
We've worked with him on it, and he said to me the other day, he said, Kevin, I think we're now at the point where he said, I really think it's that ship sailed, that idea has sailed. It's now going to be that just as you just said, we're now able to 3D print those initial quantities, or if the quantity doesn't have to be tens of thousands, we can just 3D print the whole run.
Are the customers who are buying the printers, are some of them printing parts that are sold as production parts, are being used as production parts in their products? And I'm trying to get a sense of, has this really made the jump to production, or is it still just an interim step?
It's making the jump.
Yeah.
Making the jump. And as you know, sometimes you can look at an HP jet fusion part and you would not know that it's
Right. Right. Real quickly, do you have any 3D printers that are doing metal in-house?
No.
Why not?
We came close to doing that a couple of years ago. I was feeling scared that if we don't do that, we're going to be, really left behind. But my friend Bob Delisle, who used to run the Pratt and Whitney lab, who was advising me at the time, cautioned me that this is a really fast-moving field, and that you choose a horse, so to speak, and you better hope that you choose the right one. But really, I think practically speaking, the biggest reason I haven't done it is because the level of expense to not just buy the machine, but the whole infrastructure, and the skill and the technology and the experience to run that right. It's not.
It's a huge investment for a small company. Yeah.
Exactly true. We are a small company. Yeah. Yep.
One of the ways that we reconnected in the last couple of years is that you chose paperless parts for your estimating software. You were one of our first customers around 2 years ago. I think you started using it. What problem did paperless parts solve for you?
Quite a few. In Dan Straka's words, it's removed a lot of the friction involved with our interaction with clients. We, like many people, evolved from using Excel to be able to calculate input parameters X, Y, Z, and derive that calculated amount, copy, paste. So we've gone from what was a very manual process, which was not a consistent process, quarter to quarter, person to person, and we've been able to streamline the experience for the customer in this very professional interface that's there. The customer is able to easily, quickly upload, set decisions for what they're looking for. It comes to us. We're not dealing with email. We click a link. It comes right down, which is wonderful. All of our quoters can pull that same file down and look at it simultaneously, so we can have group discussions about this. We can confer about it. We have within the system, as we've tailored it, all of our calculations for how we quote and the values associated with tasks and with materials and such like that. So we're able to just click a few buttons, get the quote generated, deliver it back to the client in what used to be roughly a half an hour per quote is down to about 7 minutes per quote now. So we've been able to, and as our RFQ rate has increased, as our company's business has grown, we've been able to increase the number of RFQs that we can produce in less time without having to hire an additional quarter. So it's been a great experience for us and continues to be.
Excellent.
It's a very wonderful thing for us. For years, we struggled with how to be able to handle this quote process and do it differently. We looked at a lot of different other options over the years, and it was painful. But now, almost all of the pain of quoting is gone.
So along those lines, thank you very much. That's wonderful explanation of how it's worked for your shop. What would you say to a shop owner, whether they are doing 3D printing or perhaps just machining or sheet metal, and they're thinking about automating their estimating? What would you say to them in terms of how to look at something like this?
I would, based on our experience, I would say you should definitely look at it. And why wouldn't you? If it's going to save, if it's going to make you, at least in terms of the customer perception, much more professional looking. If it's going to make the customer's interaction with your company easier, more enjoyable, more rich in terms of the information that gets communicated and the ease of communication. And if it's only going to cost you a small incremental cost, that cost that is there to utilize the paperless part system is more than made up for by the increase in business that we've done, and the increase of the quality of our lives. Let's put it that way. And our confidence that we're not making mistakes, and that's a big deal. You know, the potential to make mistakes in our quoting process and in our production process has been really distilled to a very, very low potential to make mistakes.
Well, thanks for sharing that, Kevin. Makes me think you've got a lot of experience, which we just talked about in 3D printing. So posing the same type of question, a job shop owner who is looking to getting into 3D printing, but not sure where to start, whether he should buy a printer or buy parts from someone like you. What would you say to somebody who just doesn't have a lot of familiarity? Let's say they're a machine shop owner. What's your suggestion, your advice to them?
Well, the simplicity with which these are operated now, the machines are so simple to operate, and the investment cost is so reasonably low now to just start that particular business within your business. If you already have the customers anyway, and if you assume that, if you're a machine shop, for example, if you assume that all of your customers are using 3D printing anyway from other sources, which might be a pretty good assumption.
Yeah.
Then why not? And manpower wise, it's almost very, very little incremental manpower involved with operating these incredible.
What I've seen is you get one of your Generation X team members to just say, figure this out, and they jump on it and they love it. What else should we share with job shop owners, perhaps, that we haven't talked about so far? Is there anything we've missed, Kevin?
I think that just to share my own perspective, the 3D printing has really changed the world. It really has. And I don't think we've plateaued. And I think that this, if it's a curve, I don't know if it's a hockey stick curve, but I think that the slope is a very positive slope in terms of the rate of how it's going to continue to make lives better, how it's going to continue to make the world better, make businesses healthier, and basically help the world. And I think that there's no wrong time to get on board with that. There's no wrong time. It's not too late to, and I think that if you're not doing it, you better really just get your feet wet with it. Find out. And
getting your feet wet doesn't have to be expensive. Formlabs printers, some of the FDM printers out there, they're a few $1,000s. It's not going to break the bank if it doesn't work and essentially you throw it away after a year.
That's true.
What do they say out in Silicon Valley? Fail fast.
Fail fast.
Yeah. Well, this has been a real trip down memory lane, Kevin. So thanks so much. Many people don't realize how long 3D printing has been around and how dramatically the parts have changed over the years, the materials, the process. It's been definitely quite a journey, and I appreciate you helping document it for the listeners. And the story about the ventilator adapter, that's so inspiring. It shows that each of us can do a small piece in this battle, that you just got to take initiative. So thank you so much for sharing and being on today. Yeah.
Thank you so much for the opportunity to talk to you. Yeah.
Where can people find you and InterPRO? What's InterPRO's website?
InterPROmodels.com, all one word. And my contact information's on there as well.
Great.
But my email is kevin@interpromodels.com.
Well, if you have a question as a job shop owner, is it okay to contact you?
Absolutely, sure. Yeah.
Thank you for doing that. And you, the listener, thank you for tuning in and sharing your day with us. We want the podcast to provide you with relevant, actionable information. So if you have any suggestions or comments, please email us through the website, thejobshopshow.com. And also, we would appreciate you sharing the podcast with others. And of course, leaving a 5-star review on your favorite podcasting platform. And now, time to get back to making sure those spindles are turning, those lasers are cutting, and those 3D printers are printing. Have a super day.